right, everybody, thank you for wandering back after lunch. Hopefully you had something to eat and maybe drink, I don't know where. We now have a couple of folks to talk to us about database. Now for some of us, databases are magic black box things, but here's the cool thing about databases. Why do you break into a bank? You rob banks because that's where the good stuff is. Hey, don't we keep good stuff in the databases?
I think so, Jack.
So I would like to introduce Josh Shaw, Martin, and Martin. Okay, so these gentlemen are going to tell us how to get to the good stuff. So enjoy.
Hi, everybody. Thank you all for coming in today. I'm going to talk loud. Martin's going to talk into the microphone. I'm really excited that we're here today. I'm excited that you're all here today. This is going to be fun. We're going to show you how to hack databases. And, my plan for today was actually kind of mellow. I was just going to talk to you about, here's the type of vulnerabilities we have in databases, and then I was going to show you some exploits and kind of how easy it is. Then I got lucky and Martin agreed to come with me. Now, Martin Rakhmanov is the guy that's found most of the vulnerabilities that we're going to talk about today. So I thought it'd be a lot more fun to spend more time talking to Martin and learning about actually discovering ODAs in databases and how we find them and how to go after them, as well as show you how to go out and, if you feel like breaking into Oracle tomorrow, let me make it really, really easy for you today. So let's start here. Just a little intro. A lot of data gets stolen every year. You all know that. Almost all the data that gets stolen every year comes out of databases one way or another. And that's no surprise, because pretty much all the data we've got we store in databases. So if you're going to steal it from somewhere, it's probably going to eventually end up in a database, particularly if you're going to steal a lot of data at once. The reason why people are able to steal a lot of data out of databases is because, well, nobody really bothers to secure them. Breaking into databases is so ridiculously easy. They're so poorly secured. There's so little organizations that actually take the security of their databases seriously that they're just a really soft target out there. It's kind of fun to go break them. So, just some basic stats. Huge increase in the number of attacks last year over the year before. Most of them were actual external attackers. Data is what people are trying to break, they're trying to steal. And it's credit card info, it's personal information, it's company secrets. This is the type of stuff we store in our databases that's getting stolen. Now, when I look at what the real problems are in databases today, like where your database is really vulnerable right now, I come up with a top 5. And my top 5 looks like this. Starts with SQL injection. So we've been talking about SQL injection since 1984, and we haven't done all that much to fix it in the web app yet. But what's interesting is that the database vendors have introduced a lot of SQL injection vulnerabilities into the databases, and those are often a lot scarier than the SQL injection vulnerabilities in your web apps. So we're going to look at some of that stuff today, but that really worries me. The number of SQL injection vulnerabilities we see inside the database is growing. And we've got password attacks. So your employees have no idea how to set a strong password, and no matter what controls you put in place to force them into a strong password, they figure out how to come up with an easily guessed password that passes their rules. That's one problem. That's not what really I care about. The more interesting problem is that there's a new generation of password attacks that we've seen come out against databases that allow attackers to brute force passwords, unlimited attempts, no logging, no account lockout, just pure entry into the database system. You start seeing vulnerabilities like that, and the whole concept of username and password authentication falls apart pretty quick. Improper and ineffective access controls, it's just something we've been seeing forever. People don't bother to set up the access controls on their database, and so they don't work. Security features kind of suck if you don't turn them on. Database Java exploits. So Martin has found in pretty much every major database in their Java implementation mechanisms that anyone with access to the database can load any Java onto the database server and run that job. I mean, the database gives you an interface to load up your malware, run your malware, and it runs it all as the database application itself. So you're pretty much always running as root on whatever box you've got. It's beautiful. And then finally, we've just got misconfigured database security settings. All the databases have security features. They're pretty much all turned off by default. Guys start to build applications with those default systems in the database. Then they go to secure the database, and then the apps don't work, so they turn the security features back off again. See them all. I asked my research team, Martin is one of our head researchers. My research team is called Team Shatter. They do database security research. Shatter's the biggest dedicated database security research team in the world. And I said to the guys, look, OWASP does this really cool thing with a web application top 10. Why don't you build a top 10 for database vulnerabilities? And so they built this top 10, and we're actually going to base our presentation on the top 10 today. So we'll walk through these kind of 10 different classes of vulnerabilities. We'll show you some exploits, but we'll spend most of our time actually talking about how we found this stuff. So let's start with logins and passwords. Every database has got them. Right? Everybody's got to have an account in the database one way or another. The database is all shipped with a bunch of default accounts. And when you install applications on your databases, they install default accounts too. All those default accounts have default passwords, and all those default passwords are easy to find on the internet. So if you leave them in place, it's kind of like you left the window open to the database. So we see them all over the place. There's also a lot of free tools out there that'll help you crack database passwords, both brute forcing tools and just tools that'll go scan every default account, default password pair to see if you can get in. And most folks don't bother to look at the login activity in their databases. So even if they're auditing stuff like failed logins of the database, you could fail to log in 7 billion times, and nobody's going to notice for 6 or 9 months until the auditor comes around and says, hey, show me those logs that you're collecting. And then it's like, oh shit, look, somebody was password attacking us 6 months ago, and I guess they were probably successful. So just a couple of examples. Oracle is kind of the king of the default account. They ship about 40 accounts with the database by default. Pretty much all of them have the username and password set to the same value. So when you set your password to your username, that's kind of a pretty shitty choice for a password. But Oracle does it all the time. My favorite is the DBSNMP account. DBSNMP stands for Database Security Not My Problem. DBSNMP's password is DBSNMP. I find it on almost every Oracle database I look at. I can just walk in, Oracle production system, type in DBSNMP, and it logs me right in. DBSNMP is like an account that Oracle uses for enterprise management. Pretty much nobody fucks with it. They leave it alone the way it was right out of the box. And it's not a privileged account, but it's so easy to escalate your privileges to sys from there. It's kind of scary. So I see that all the time. The other databases have usernames and passwords too. SQL Server and Sybase have their SA, their sysadmin account, and the default password is blank. So SQL injection. Same concept with a web application in the database. Now think about inside a database. Inside a database, I do things like I can create tables. I can put columns in those tables. I can create databases and give them names. There's a whole bunch of stuff inside a database where I can put input in. Databases also have functions and stored procedures. Code that runs inside the database. A lot of times those take parameters. A lot of opportunities to inject SQL inside the database. So let's take advantage of SQL Server. This will be our first exploit. This is one that Martin found. Martin, would you show him how to hack SQL Server 2008?
Okay, folks. So we're going to talk about different SQL injections today. And the first one is about SQL Server internal SQL injection in restore database comment. So I was looking in the SQL injections, which are kind of hard-coded in binaries of applications, on the contrary of many SQL injections are in packages or procedures. And I was trying to find something which is hard-coded into the server itself. And I had an idea that such code will be most probably executed without any privilege checks or with the highest possible privilege level. So I did a search for various types of SQL commands like select, insert, delete, exec in the binary, and eventually came across one called for stored procedure, which is replication-related stored procedure, and it is executed when you restore the database. And fortunately, it has a parameter which is database name. And I tried to play a little bit with database name to get my own code injected into that. So let's see how it works. First, we're going to show you a demo, and then I'll explain how it works. First, we're going to create a user. We log in as a privileged account and create a login hacker Harry for that exploit, and also create a user and grant the create database. This is important because this attack requires us to have certain level of access to the server, and this is quite powerful privileged create database, but sometimes you're going to get it, like when you create your database, install database for some application, you're going to be granted this privilege temporarily, or on a shared server environment when you can back up and restore your own databases. So you're supposed to have this privilege. Now we're going to log in as a hacker carry. Okay. And we're going to download the server version. This is a SQL Server 2008. And we're going to try to select the password hashes from syslogins. As many of you know, in SQL Server 2005 and later, there is a protection which doesn't show you any logins besides your own, and also it hides password hashes from you using null bank if you are unprivileged user. This is what we see here. And obviously, any attempt to grant ourselves any server role will fail. Yeah, right, and fail. And also, we were unable to switch database context for master unless we're granted any privileges. In this case, we tried to switch to sample adventure work database, and it also fails. Okay.
So we got a low privileged user here.
Yeah.
They can't do much, but they can create a new database on this install. And let me give you a little context to the way SQL Server gets used out there. When Microsoft licensed the SQL Server, it's not licensed by the capacity of the server. So what folks are doing is they're consolidating lots and lots of database servers into one big honking SQL Server installation. And so they'll put 50, 100 different applications into one SQL Server. They get like 25 different administrators that are all segregated out with different permissions, and you manage these apps and you manage those apps. But then they have just one SQL Server license and just one piece of iron that they're dealing with. And so you have these big, juicy targets to go after. They have dozens or hundreds of apps all in this one juicy target. And there's a lot of people who have some level of administrative rights on those particular systems. And it shouldn't be dangerous to be able to create a new database, as you can see, because you can't get into anybody else's data that's already on that database.
Okay. So now we're looking in as a hacker carry, and we're going to create a database with very, very special name. As you can see, we already embedded a special string in the database name, which is going to grant us sysadmin role upon execution. The next step is to perform a database backup, because the trick is to make a backup, modify a backup copy, and restore it to trigger this vulnerability. And we can drop the database in the next step after the backup is completed. All right. So the database name is very special and has to be in square brackets. Okay. We can back up the database on a network location, even CPAP. So it doesn't have to be a SQL Server box itself. It can be on the network. So suppose we back it up on some location, and now we need to change just one byte in this backup. We'll open it in any hex editor and locate the database name, actually the third occurrence, I think, and change just one byte from 27, which is a hex for single quote, to 07. Why do we do that? Because Microsoft internally does some sanitation, and if it sees single quote, it's going to be escaped by double single quotes, as you usually do for your quotes. Yeah, you just escape them in web apps. However, we give special meaning to 07. 07 is going to be replaced by a single quote.
It's magic, right? They put this protection in place so that you can't stuff a single quote in. But then they make it so easy to stuff a single quote in if you can get your hands on the file. And you get your hands on the backup file because Microsoft is happy to send the backup across the network to any system that's sitting on the network talking to it. So it's real easy to kind of get your hands on the backup file and inject a single quote if you know where to look.
So, sorry. What's going to happen on restore? The server will find the database name in the backup file, parse it, and replace 07 with single quote, and then use the result as a database name in several of internal SQL sentences. And one of them is, as I said, is a replication-related stored procedure call. And the parameter will be database name, and it will be passed as is. It's going to be like a single quote, 3 zeros, and then exec our own code, and then command sign at the end. double dashes. Okay, we run this restore command through dynamic SQL because we had to add a 07 special character. And now I think we have a sysadmin role. Let's try it. We reconnect as hacker carry and double password hashes. So we see a lot of users now, a lot of logins, and non-null password hashes here. And also we can grant ourselves any row. In fact, we already have sysadmin, just a double check. And we can switch the pages. That's it for this particular exploit.
So, I think this is a good one because of the way people deploy SQL Server with all these different databases kind of consolidated. Martin reported this to Microsoft at least 2 years ago. Microsoft eventually got back to us and they said, this is lateral escalation by our definition. You've gone from administrator to administrator in SQL Server, and so we're not going to fix this. So this is an O-Day. This is not going away. This is there in every SQL Server 2008 installation. I don't believe this is lateral escalation in any way, shape, or form. I mean, you just saw us go from almost no privilege in the database to complete ownership of the server and everything that runs on it. This one horrifies me. I've tried hard to convince Microsoft they took the wrong approach, but they have their lateral escalation rules and they know what they are. But this will work on any SQL Server 2008. Try it.
Essentially, you just need base rights to the SQL server, so regular user.
Regular user with create database. So if you go out and say, hey, look, I'm going to evaluate this new vulnerability scanning tool, and it needs a SQL Server backend, so just create me an account, give me create database, and I'll install it. You can take it away in an hour. I never had anybody say no to me for that, and I've asked hundreds of organizations. We happen to sell, a vulnerability scanning tool that needs SQL Server for the backend, so we've asked a lot. So let's talk about privileges. Excessive privileges, you give somebody access to something you don't want them to have access to, and they have access to something you don't want them to have access to. I mean, it's kind of straightforward, right? The thing is, in a database, the access controls are super complicated. You've got privileges you can grant to users, you've got roles that you can grant privileges to, you can grant roles to roles, there's implicit privileges, there's all sorts of privileges in a database, and the damn database will not tell you what your privileges are. Unless you're talking to MySQL. MySQL's got a super simple permission system, not very powerful, very simple, very transparent. Oracle, on the other hand, oh my God, cannot ask an Oracle database what privileges you've got, who can look at this table, who can change this data and get any answer. The database can enforce the privileges, it just can't tell you what they are. So, there's some best practices. Pretty much don't grant privileges directly to users, grant them through roles, and make your roles simple and manageable. But the easier thing to do is just to take a user, like cut and paste the definition of that user, create a new user, and you're off and running without thinking about roles. So we see a lot of directly granted privileges out there, which isn't a risk in and of itself. It's just a problem when you go to change somebody's permissions, and you've got to think about every permission they have and every user in that particular job. It can be a mess. And then finally, databases have public. Now, public is like a group that includes every user in the database. You can't make public go away. There's tens of thousands of privileges granted to public by default, so you can't even manage public privilege. If you take those privileges away, the database doesn't run anymore. And you go ahead and try to figure out which of the 37,000 privileges granted to public in an Oracle default installation are important or not. Because Oracle certainly ain't going to tell you. So you can go test every one of them, take this one out and see what happens. But we're kind of all stuck with this privilege issue where public is this big mess and there's very little we can do about it. Unnecessary database features. So here's another big one. We all talk about surface area in the security business. And, cut down the surface area, give us less code, give us less places for a hacker to go after. Well, if you're in the database business, your goal is to put as much functionality into your database out of the box as possible, right? Make it easy for people to just start up their apps, get them going, whatever features they want, whether that's Java, XML, locations, services in the database. I mean, there's so much stuff that just gets installed by default, including lots of functionality to access the operating system through the database. So let's access the operating system through the database. Martin, why don't you show my next slide?
Okay. So this is actually about the Java enabled in database without any need. In Sybase within 7, you can enable Java, and it can be invoked by any user without any privileges set. Absolutely. So what we're going to do is run any code in the context of a server process via Java. First, we're going to examine the server version, which is within 7, the latest version of SidesRI available. We're going to add a demo login to that. Okay, so this particular exploit is going to run code from a dynamic library. On Windows, it's going to be a DLL, but it works on any platform, on Solaris, on Linux, for shared object also. For this particular exploit, I've chosen this Windows application. It's going to load the library which will run a system call, which will in turn run a built-in Windows command OMI, which will bring all your privileges and redirect output to eval.log file. So I first wrote this code and compiled it into a DLL and put on some location. For simplicity, I put it on a C drive, but it could be any network location also. On the C drive of this Sybase database server. Now we log in as a James, and now we're going to try to load this DLL through Java. We declare a variable and call a load method. And apparently it should fail because of the security restrictions put by Sybase inside Java implementation. They put a Java Security Manager implementation which prevents you from loading any libraries. This is good. However, we can bypass this. We use a Java reflection classes to get a security field of a security manager here and just set it to null. And that's it. You can load the library.
Hey, that's not funny. The biggest banks in the world use Sybase. This is serious.
Okay, you should say that's something. No, okay, it worked. And now if we look for eval.log on the hard drive of the machine, we're going to find it on the system bed 2. By default, Sybase server is installed on the system, I think local system account, right? So here you see the username with the authority system, a lot of privileges. Basically, you can run anything. This requires no access except connection to a database machine with Java enabled. That's why you should now enable unneeded options.
So I doubt too many of you guys are database administrators, but what was interesting about this attack for me was the way we created that user. All we did was give them a username and password. In the database, you have some public permissions by default, and that's what I mentioned, but we didn't give them any privileges at all in this database. Just create a user, it's the lowest privilege user you could possibly have, and they were able to load and run arbitrary code. I mean, Martin was friendly and wrote who am I, but you could also probably stuff Zeus into a package and get that to load up on this server.
Was that the Java security subsystem that you used to just elevate to allow you to go in there, or did you use?
I just bypassed Java security subsystem, which was incorrectly implemented by Sybase. Basically, when you plug in Java into the base, you have to write security manager implementation properly, and it wasn't done here. This thing is already patched, but there are other similar vulnerabilities in Sybase still.
Martin last year found a rash of Sybase vulnerabilities. We just started looking and we found a ton of them. Sybase has been working its way through them slowly, but there are there's some pretty ugly ones, some really simple to exploit ones that are out there. I think we'll show you another Sybase today. So broken configuration management, again, if you don't set up the security settings on the database or any other piece of software, they just don't work. The troublesome thing with databases is that very few people know what a secure database looks like, or have some standard that says these are the way that the settings should be set properly.
People aren't using the disestate.
So there's two options that are out there in like kind of the public domain. You got the disestate, which explains every setting in like the database and tells you how to set it, but it's pretty heavyweight. You know, it's kind of geared up towards military and it's great, but most folks who use it kind of water it way down. Then you've got CIS, the Center for Internet Security, also publishes a database benchmark, which is pretty good too, and it goes through all the settings. And I mean, gee, it's like not super rock solid, but if people use it, it'd make a big difference. Well, but I'd say maybe 10 to 15% of organizations that I see have adopted one of those two standards. And maybe another 10% of organizations have an internally generated standard. But that leaves you with like 70, 80% of organizations out there that don't have a target. And it's so hard to hit a target when you don't have the target to hit. Like how do you ask people to go and set up a secure database when there is no definition for what that looks like? So just a couple of examples. Oracle configuration management is a piece of Oracle that leaks a ton of data. Microsoft installs on default ports 1433 and 1434, so Nmap finds SQL Server like you wouldn't believe. Sybase has got an auditing system that if you don't set it up exactly, perfectly, correctly, you lose audit records very, very easily. And my all-time favorite is the security knife switch on DB2. This is both on the distributed and on the mainframe version of DB2. It's a parameter called trust all clients, and I call it the security knife switch because it literally is. If you turn trust all clients to yes, that turns off authentication and authorization in the database. Just literally turns off all security features in the database. Now, I've been in the software business for like a while, 10 to 15 years, and I've learned that when you put features in your software, even if they're stupid, people use the features in your software. I see people turn trust all clients on in DB2, and I ask them, like, what are you doing? I don't really know. Why is that a big problem? My hair's on fire. Why is that a big problem? It's there now. I don't know why it's there, but it's there. So, we haven't attacked Oracle yet. Can I do this one?
Yeah, sure.
Right. So this is a fun attack. This is 11G release 2. It's the latest version of Oracle. This does not require a database login to execute. I love the attacks that are completely unauthenticated, network-based. I mean, those are the most fun for me. Now, what we're going to do here is we're going to be able to take complete control over Oracle. We'll also be able to watch anything that's going on with the database. So we're going to do this by exploiting a vulnerability called TNS listener poisoning. So let me give you a little information about Oracle architecture and the listener, and then I'll show you the attack. So this is the way kind of Oracle's set up. It's got something called a listener, and the listener is sort of a proxy. When you want to talk to Oracle, you talk to the listener. And the listener will tell you where the database is. So basically, the listener is on a known port, and then the listener tells you that the database is on some ephemeral port that you're going to go talk to. Right? So eventually, you end up having a conversation directly with the database. So the listener is kind of like a lookup service for the database. So with this attack, the attacker comes in and sets up a proxy. The attacker then poisons the listener. Once the listener is poisoned, the listener will start sending connections not just directly to the database, but also to the proxy. See, the listener is set up to allow you to do clustering. So Oracle's got a clustering system, it's called RAC. And when a listener sees two databases set up with the same name, it says, hey, I must have a cluster. I'll start load balancing between these two databases. Right? What we're doing here is we're adding another database with the same name as one that already exists, and so it's going to start to load balance. And some of the connections that are destined for the database are going to be load balanced to the attacker's proxy. The attacker then proxies those connections off to the database, right? So now he sees everything that happens, but more interestingly, you drop any disconnect commands, and now you own the session. So the attacker can now talk directly to the database. The reason why this attack is anyone on the network is that there is no authentication required to add databases to a running listener. There's just no security around it at all, beyond the security. It's a protocol that Oracle doesn't publish, and then if you don't know the protocol, you can't add a listener. What's the first thing you do, right? Wireshark, let me add a listener and see what happens. Guess what? I know the protocol. So this vulnerability was actually discovered by a guy named Yaksin Korid. He discovered it. Oracle tried to sort of fix it and didn't, and then it got out there as a 0-day earlier last year. There's a fix out for this now, but not a lot of folks have implemented it. So here's my database server. I'm running on the database server. The only interesting thing here is my IP address. My target database is on .193. So here's my attacker system, or here's a client system, I'm sorry. Regular client going to connect to the database, connects to the database with a privileged user, can do privileged user stuff like select usernames and passwords from where the database stores them. This is a DBA, you can do this. So I can get my sensitive data. Now here's my attacker system. Yoxin, when he published this vulnerability, published a couple of Python scripts, made it easy. So one Python script he published was a proxy, just a TNS proxy, so this will proxy Oracle connections. So I'm going to set up the proxy. Right, I want a proxy with the target database as the remote IP. I've got my own local address in there. Port 1521 is Oracle's default port. So I run the proxy, and then I'm going to run the actual TNS poison script. So there's another Python script out there that will add a new database into a running listener. Right? So he took the protocol and coded it all up in Python for you. You give it the database name, and it'll go on and do that for you. The database name in there is that ORCLDB thing. The data that's dumped is actual the manual proxy registration, so you can see kind of the Oracle DB in there. And now we go back to the regular administrator, right? So regular administrator goes to connect to the database. Now the listener is going to start proxying his connection, or he's going to start load balancing his connection. So the first connection goes directly to the database. The second connection goes to the proxy. So now, on the proxy side, it starts dumping data out onto the screen. And here it is. I mean, we just saw the DBA do this select name and password from sysuser $. Here's the sys coming back. Here's the password hash coming back. I'm just able to read the clear text communication between the client and the database and pick up any sensitive data that's there. But again, now that I own this connection to the database as a DBA, I run any commands I want. I'm logged into the database as sys or any DBA account. I have no DBA account of my own, but I can create one now. Yes, sir.
So does that mean that somebody has to execute a command on that database?
Somebody has to connect to the database. Not just execute a command, but they actually have to make connections. So you may sit there for an hour, a day, a week, waiting for somebody to log into your database before your proxy lights up with a connection.
Okay.
But eventually you'll get
It echoes back to you.
it comes back to you because it's load balancing between the real database and what it thinks is the other database in the cluster that's really your proxy. Buffer overflows. I think database buffer overflows are boring, and I think you should give up on them because, like, why bother with a buffer overflow when I can just load and run custom Java code? Isn't that more exciting and fun? Oh, but there's buffer overflows anyway. We just show them how to crash DB2.
I'm sorry. Some time ago, there was an exploit published on network and the internet showing how to crack DB2 through built-in repeat function, which is publicly available. So anyone can run this command. Just a one-liner. You just connect to the database and do select repeat and non-repeat with a huge amount of repetitions inside. So it's gonna allocate memory, 1K memory, and then it's gonna be repeated a million times. So it's gonna eat up entire memory. The process will die. If we go to the event log, we're gonna see DB2 service is dead. So it's a DOS at least. Just a one-liner, and I think it's not possible to mitigate this vulnerability. You can revoke permissions to run a repeat command in DB2.
No more database. I presented this once, and somebody said, "Well, who cares? Why do I care if my database goes away?" That's exactly what I said. Okay. Don't worry about it. This is a good one because this function, I mean, like you type DB2 repeat overflow into Google, and the first link is the exploit code. So this is the kind of exploit that I like to find and run with because it's that easy. Privilege escalation. So a lot of what we've been doing is escalating our privileges. But it's fun to escalate our privileges, right? It's fun to be the DBA. Sybase again. This is a good one. Please.
Okay, this is an outside-based exploit, very similar to SQL Server. So, again, this is 15.7, latest version. All we need is ability to connect to a database because create database and create index are granted by default in TabDB to any valid user. And we're going to gain a SA row at the end. All right, let's do a demo. Again, it's like version 15.7. in Genius, which was just created. It's unprivileged account, just kind of login. We display rows. Nothing is granted to this account. Alright, now we switch to tab DB. Set code identifier optional to allow us to run to use special names for objects. And we're going to create a table, just a dummy table, and we're going to create another table with a very special name. That's why we need this code identifier option. In double quotes, we can put anything like this SQL we want to run. And we're going to create an index on the second table. Alright, something went wrong. What happened here is server tried to create an index, and because of a problem in input sanitation, it executed code we supplied as a part of the object name, this grant rule, and it didn't get back expected number of rows or something like that. That's why it says some error occurred and killed our connection. But now we can reconnect and see if we have any rows. Here we are. We have SA role and SSO role rendered for this exploit.
So this one is this one's awesome. I mean, any user in Sybase has got this temp DB thing, so you can create temporary tables, and temporary tables are used very, very commonly in databases to collect some data and report it or show it on the screen. In Sybase, everyone has the right to create a temporary table. It's irrevocable. There's no way to take the privilege away to create temp tables. Even if you deny the privilege to create table to a user, they can still create a temporary table. And if I can create a temporary table, I can create an index on that table. And if I can create an index on a temporary table with the right name, I can run this exploit. So no privilege is needed beyond the ability to log into the database with a guest user or any other low privilege user. I love that it gives you an error in the process of granting you full control of the database server too. So we got unpatched databases. Pretty much all this stuff is patch-driven issues. The vendor made a mistake in their code. That code needs to be patched to be fixed, and it's really a pain in the ass to patch your databases because there's some application that sits in front of the database, and that application is not allowed to go down, and the patch is invalidated with the application, and there's 17 other excuses for why we, the database team, can't possibly apply that patch for the next 9 months. So you need to live with it, right? Finally, we've got crypto. I think database encryption is kind of stupid. I really do, because most of what it does is nothing. Databases have these like access control systems. So if you don't want somebody to have access to data, you don't give them access to the data. That's usually what you use crypto for, right? It's access control. But there are these DBAs in the database that don't observe those access control rules. They can see any data they want to see. So the idea behind crypto is maybe to keep those DBAs out of the data in the database that they administer. The problem is that pretty much every database encryption system is run by the DBAs. So the only people you could possibly get any benefit from keeping them out of the data is the DBAs, because everybody else is just deny access to data you don't want them to have access to. You encrypt the data so the DBAs can't see it, and then you give the DBAs the keys to decrypt the data. And you have spent some time and money, but you haven't done much. Now there's some things you can do. It's useful maybe to encrypt the disk, so if somebody steals your disk, or if you run backup off disk instead of through the database, maybe you can encrypt the data out there. It's useful to turn on network encryption in case somebody puts a packet sniffer in front of the database. Maybe they won't get all the data from the database. That network encryption stuff with the client is pretty darn easy. But most people think of this, I'll just encrypt my database data as the silver bullet. And folks like the PCI Council are making it worse by saying, here's a requirement, encrypt your database. Like, well, why? What do they get at? But there are some options out there. It's absolutely the last thing you should do from a security perspective for your database. But, well, again, kind of got to balance it out. There's some benefit, but not much. Particularly not with inside the database, I'm going to encrypt my live data. Number 11. Like most folks, like I said at the beginning, just don't do anything. Right? The easiest thing to do about database security is to go ask the legal team, and the legal team will tell you that you're far better off not having any knowledge of your database vulnerabilities at all. And a lot of folks tell me that. I mean, I talk to a lot of CISOs who say, look, you know, the stuff that you guys do, this information you can provide me around my databases, I'm better off if I don't know. Well, of course you're better off if you don't know until somebody else like steals the data and it's up on Pastebin and you look like a jerk. But we see it happening a lot. And so we've seen it happen to like, you know, important, powerful technology companies, Yahoo and LinkedIn, Sony and Epsilon. Department of Veterans Affairs announced that they think they've been hacked by China for the last several years, a couple of days ago. It's all over the place, and it's just people aren't doing anything about it. Yes, sir.
I do a lot of application security testing, and one of the things that I run into communicating with customers is I have a lot of data from like web hacking incidents and all these different places where you can show SQL injection, cross-site scripting, you can show that, but like database vulnerabilities specifically where they're doing like privilege escalation and all of that inside of the network, I don't have a lot of statistical data to back up what I'm saying. I'm curious, when you run into that, what are you telling the customer?
I got the same problem, to be honest with you, because I can show you guys database vulnerabilities that are like, drop your jaw all day. And I can't show you any examples of people taking advantage of it.
Right, so.
I can't. As far as I know, every hacker out there is too fucking lazy to bother to point their target at Oracle and run these simple exploits. Because I don't see it happening, and it blows me away every day of my life that people aren't tearing the world up with TNS listener poisoning and with these Sybase exploits. I mean, Sybase last summer said, hey, we fixed 12 vulnerabilities. 10 of them they didn't do anything about. So they announced 10 O-days. Nobody exploited any of them. I mean, they were as simple as can be, one line of SQL exploits. So it blows my mind. I don't understand it. It's like the mystery that I wrestle with every day of my life is why don't people hack databases directly if these vulnerabilities are there? And maybe the answer is that SQL injection through a web app is like I download a Vij and I point it at my website and I'm done and I don't even have to think beyond that. I don't know. Or maybe it's cooler to get like control of somebody's webcam and snapshot them sitting at their desk as part of your pen test and say, you know, look, I own your laptop. I always thought it would be cooler to say, you know, look, I own your financial reporting system, but I don't know. But I don't have stats. I don't have examples. I just have like technical evidence that this is trivial to do, and you know, if you try it, you'll have success with it. Maybe people are burying it under the carpet. They don't realize that's how they're getting exploited. I don't know. I wish I had a better answer. I probably have a lot more money in my pocket. Yes, sir.
How does Postgres stack up against the commercial offerings? I know you did a couple of examples of it.
Postgres and MySQL, I'll put them in the same bucket. They're both pretty decent from a security perspective. We see some vulnerabilities come out every once in a while, and sometimes they're pretty dumb and pretty scary. But with the open public review of the code, it hasn't been too bad. At the same time, those databases are simple. They have a lot less features than Oracle or IBM have. And with that simplicity comes just a lot less opportunity for mistakes, right? Less code means less bugs, means less vulnerabilities.
They're not as readily used in the enterprise either.
It's not. And you've got like some packaged versions of Postgres like Enterprise DB that make it better. But the truth is, for most of your enterprise apps, Postgres isn't gonna do the job. Or your database administrators are gonna tell you that I don't know how to make Postgres do the job.
Yeah.
So I gotta stick with Oracle. And that's really one of the big problems out there. Is like we stick with Oracle. It doesn't matter what Oracle does to us, what their business practices are, how vulnerable they are, how bad their code is, what a jerk their sales rep is. We still, like, there's nothing we're going to do to stop running Oracle and Oracle apps. They're still out there. So I mean, that's kind of the issue. Postgres is great. If you start a new app, it's a really, you know, it's a good option if it's got the feature set that you need, and if you've got the people that are willing to support it. Yes, sir.
Do you think that all this vulnerability research is beating down vulnerabilities in databases at all, or do you think that new code is outrunning the research?
What do you think, Ryan?
Could you please repeat this?
Is it harder to find database vulnerabilities now than it was 2, 3, 4 years ago?
Oh yeah, especially in SQL Server. It's a very good product from a security standpoint now. But for Oracle and Sybase and DB2 probably there are a lot of issues still.
honestly, Microsoft's done an awesome job. With the exception of this vulnerability that we showed you today, there's no known vulnerabilities against the current version of SQL Server. So they took it seriously, and one of the things that Microsoft does is they actually put a decent number of security controls on by default. And so it helps. So like I just stand up like a brand new SQL 2012, and I can't just break into it. Whereas I stand up a brand new Oracle 11G release 2, and the door's wide open to break into that. So that's kind of an interesting thing. In the database world, Microsoft is far more secure than Oracle and any other vendors out there. Yes?
So, how do you go about finding these vulnerabilities? Reverse engineering?
Oh yeah, you have to do different stuff like reverse engineering, or you may approach it differently using some fuzzing techniques. So it depends what you want to do, like just dumb search and be lucky, or just focus on some particular area of the database and find an issue within this area.
One thing I've seen a lot is the same developer makes the same mistakes a lot of times. And you don't know which developer committed which code, but you find families of code. So like some of the code for like creating indexes or creating tables is a good example. If the developer who wrote the code that does the create table allowed you to inject SQL in the table name, there's a good chance that every other table-related administration function was written by the same developer. So you find one vulnerability, and then you go look for every other similar piece of functionality, or you go after every other parameter in that same function, and you may find vulnerabilities fall out of the sky. And I see that a lot. Like if I look at our list of vulnerabilities, you see these groupings around very similarly named functions, because they're all in the family of like Oracle Spatial, or they're all in the family of XDB or whatever. And you just, there's 5 parameters. Look at all 5 of them are vulnerable to SQL injection. And hey, there's 4 other functions that have almost the same name. And look, their parameters are vulnerable too. That's often how we find a lot of these vulnerabilities. It's like a snowball kind of.
And sometimes there's just add a function to sanitize user input in one place, but forget to do the same in another place. So it's kind of partially fixed vulnerability. You have to double check.
What do you use, like IDAPRO, like sort of IDAPRO?
Oh yeah, IDAPRO is a good example for reverse engineering and Python tools.
What about some of the newer NoSQL stuff? Are the engines different on the back end where you can't do these things, or?
I would assume that the newer stuff like Mongo and Greenplum and whatnot all have the same types of vulnerabilities. I don't know of a researcher out there that's looking yet at those type of systems.
It's not as sexy.
It's not just that it's not as sexy. There's certainly not as many of them out there, so it's not going to be as fruitful. It's interesting, and at the same time, though, as I look at Mongo. Mongo's a good example. There's no security in Mongo. The idea behind Mongo is put it on a secure server, put security externally, and then the database is what it is. So it's kind of hard to look for security problems in something that doesn't have any security to begin with, right? So it's like you're trusting the environment for security, and we know that. Yes, sir.
Have you found many vulnerabilities in cache?
You ever looked at cache?
No.
Well, you're out of questions. We're out of time. Good deal. Thanks for having me.